Hello guys, welcome to the channel. In this particular video, I will explain the problem easy task. This problem is based on the concept of segment trees. So let's see the problem statement. Here is the problem statement and it says that given a string whose length is n and array queries of length q where each element of queries is either of type 1 query or type 2 query, which is explained ahead. So the type 1 query is given in this form and here 1 represents the that it is a query of type 1 and the we need to change the value of index to char. Let me explain it. So if we have a string like ABC, then and a query 1 type is like this. I have 1, then I have 2 and then I have D. This means that I need to change the value at index 2 to D. This means that this is the index 2, so the value will become ABD. This is what the query 1b means. Okay, now you can see that this is a type of update query. Let's talk about the query type 2 now. So query type 2 is represented something like this. Here 2 means that it is a query of type 2 and we need to for like this given range left and right, we need to find the kth largest character. So it is basically lexicographically largest character. Now let me explain this as well. So if I have A B C D E A B F M N and we are given this particular range in the form of left and right. So this is basically as it is following zero based indexing, so it will be 0 1 2 and 3 4 5 6. So range will be given like this. Left is 2 and right is 6. Now we need to return the kth largest element. So let's see k is equal to 1 here. So this means that the kth largest element for this particular case will be f. Now this is what these two query type means. Now let's see the problem statement. The problem is you have to perform each query in the same order as given in the queries form and return the array result such that result array contains the answer for each query type 2. So only query type 2 is something which is going to give us the answer, because here we need to return the kth lexicographically largest character, but in this case we just need to update the values, right? So this is going to return nothing. Now this is what we need to do. So one example is given here. Let's see the example. The example says that we are given this string and there are two queries. The first is type 1 query, you can see here, and the second one is type 2 query. For the type 1 query, I need to update the value at index 2 to D. So if this is AB, then it will become I need to update this value to D, then it will become ABDB. Now the second query is for the range 1 to 3. So 0 1 1 2 3, for this particular range I need to return the kth largest character and k is 1 here. So if k is 1, then this means that I have to return the first largest character, and first largest character among B DB is going to be D, right? So D is the output here. Now I hope you have understood the problem well. So let's talk about the solution. Okay, so you can notice here that the problem is basically finding the kth largest character. This is what we need to return for each query of type 2, and for query of type 1 we don't need to return anything, we just need to update the value, right? Okay, so let's say I have a string which is ABFMNOPAB. I have this string, and for this string I am given this particular range. Okay, so let's not take any range for simplicity. I'm just going to ask you what is the third largest value for this given string, lexicographically largest value. Okay, so you will say that I can do one thing. I can sort this array, right? So if I sort this array in descending order, then I will have the largest character as P. After that I have O. After that N, M. After that I have F. Then I have B, 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 and A, A, A. This is how it will look like after sorting in the descending order. Okay, so let me verify it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, now as I have this sorted array, so I can simply return the kth largest element, right? from the first index, I just need to go to the third index. So okay, I need to go to the second index because it is following the zero based indexing. So this is something which is the third largest element, right? Okay, now I hope you have understood this thing, but the complexity of this thing is going to be of n log n, right? Isn't it? You can see here that we are performing the sorting operation. So sorting takes of n log n, but we can do the same task in just O of 1, which is constant time. How we can do this? This is something really interesting. Let me show you. So if I have the same string, so what I can do is I can store the frequency of each element. So I have a 2 times, okay, then I have b. Okay, so I have A 3 times and B 3 times, right? And what I have else is I have F 1 time. After that, I have M 1 time, N 1 time, O 1 time, and P 1 time. This is what I have. So 1, 2, 3, 4, 5, 5 plus 6, 11. Okay, now our task is to find the third largest element. So what I'll do is I'll start reversing from this particular element. Now, you are going to ask me a question that how to store these character to the map, right? So how we can store these characters? Instead of writing this, I can make an array, and the size of this array is going to be 26. Why 26? Because we know that there are total 26 characters in the alphabet. So at most I can have 26 different alphabet in the string, right? Okay, so what I can do is I can make an array, and this is going to store the frequency of each alphabet, like A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, and U, V, W, X, Y, Z, something like this, right? Okay, now I can store the frequency of each character here. Initially, the frequency is 0. Initially, the frequency for each character is 0, right? Okay, now what I can do is I know that I have A 1 time, A 2 and A 3 times. So I can write A 3, B 3 similarly, and then I will have F 1, then I will have M and O P 1 time, right? This is how we can store this in an array of size 26. So let's call it frequency array of size 26. Okay, now in this array, we can start traversing from the last. And because we need the kth largest element, so what I will do is whenever I find an element, I'll decrease the value of that. I will decrease the value of k by that particular frequency, right? Because when I have p, so the frequency of p means I have p that many times, right? In the sorted order. So if I have p 3 times, then I will write p p p. So these many times I have p, and if my k is in this range, let's say I have to find the third largest element. So you can see that frequency is something which is greater than equal to these three. So this means that even if I need to find the second largest element, so in that case my answer will be p, right? Okay, so I can write some logic in order to find this. Let me write the logic. The logic is pretty simple. I'm going to traverse this array from behind. So I'll do something like 4 I equal to 25. I smaller than I is okay. So in that case, I should be greater than equal to 0 and I minus minus. Now what I'll do is I'll just check for the frequency. If frequency of I is something which is smaller than k, this means that this is not going to be my kth largest character. Let's say my kth, I need to find the fourth largest character, and this is there is only one p, right? P frequency of p equals to 1 means I have only one p, so I will reduce the value of k by frequency. So k will be k minus frequency of I. This means that I have processed these many characters, right? Okay, after that, if my frequency of if my frequency of I is something which is greater than equal to k, let's say I have decreased by 1, again same for this, same for this. When I decrease this by 1, even for this case, my frequency is something which is equal to k, right? And even if it is greater than k, let's say it is 2, in that case I can do k. Okay, in that case, even this I is going to be my answer. Current index is going to be my answer. So how to convert the current index to character? I can simply do I plus a. This is going to give me the current character. So this character will be my kth largest character. I have simply written this, right? Okay, so this is the logic that we can follow in order to find the kth largest character. This is for kth largest character. Okay, so now the task is simple, that we can find the kth largest character. So what we'll do is, if we have the query of type 1, so okay, so what I have is, if I have the query of type 1, then I can simply update the value. So I will do something like string of index has become now character. This is what I can do if this is index and this is character, like for this case. Okay, this is for query of type 1, this is often, right? And for query of type 2, I can store the elements from in this range, right? Left to right I can store all the element, and then I will have this frequency array. In that case I will have this frequency array, and then I can simply do this particular task. I can do this particular task. The complexity of this that approach will be O of q cross n because I'm still traversing in this particular range, right? Okay, so is this the optimal approach? No, this is not the optimal approach. We can reduce this particular complexity to O of q log n, and this is something which is the optimal approach. In order to write this approach, and this is not even going to be accepted, it may be possible that it will get accepted for the Java compiler, but or even for the C++ compiler, but this is not optimal. This is not going to be accepted for Python, right? So we are going to talk about a very interesting approach which is based on this segment tree, and the complexity of that approach will be O of q log n, right? And even if I write in detail, then it will be O of n plus q log n. Okay, now let's see what we can do. Let's see. So first of all, let's talk about segment tree a little bit. So basically, segment tree in computer science is also known as a statistic tree, and it is a data structure which is used for storing information about intervals. Very important point, guys. And after that, or segments, and uh, it allows querying which of the stored segment contains the given point, right? Okay, so this is what we want. This is what we want for this particular problem, and even we need to store information about the interval, so both requirements are completing. So we can use the segment tree in order to solve this problem. Let's see the structure of segment tree, how it looks. Okay, so here I have written the structure of segment tree. You can see that. So what segment tree does is, segment tree is basically used to store information about intervals, right? So if I have a string like a b c d e f, this is a string, and this is 0 interval, this is 5 interval. So in this range, this particular interval is going to give me the answer. For 0 to 2, like for this range, this will give me the value that I want to store, and for this range, this will give me the value for this range. But what value I'm talking about, this is the question. Okay, so this value actually varies. Like what we want to store, this is what I will get. Okay, now according to the problem, each segment will store the frequency array of that range, right? Why frequency array? Because we want to get this frequency array in an optimal manner, because when I'm doing this way, then it is taking off n time to get the frequency array, right? But I need to decrease this time. So if I use segment tree, then I can get the same frequency array in just of this particular time. This is something optimal, right? Okay, so segment tree is basically used to reduce the time complexity of searching. And searching for what type of queries? Searching for queries which are based on intervals, right? You can see that 0, 5, 0, 2. So I can get the answer for any of the interval. How to get it? First of all, let's talk about how it is going to store the answer according to our problem. So I need to store the frequency array for each interval. Let's talk about how we can do this. So initially I have the interval 0 to 5. So after that, I'm not going to store here. Instead, I'm going to move to this particular place. Okay, and this particular place. Fine. Now I'll go to these 2 points, and for this as well, I'll go to these 2 points. Okay, and again I'll go to these 2 points and then these 2 points. When I'm at these particular points, these are very important points. How? Since I have only one value here, so and the current index is 0, you can see that this is interval 0 0, right? So I can store at this interval this particular index. At this point I'll store, I have a1, right? Okay, and what about this 1 1? For this 1 1, I'll store, I have b one time. Fine. And after that, for this particular thing, I'll simply store, I have c one time. This is index 2, and for this index 3, I'll store, I have d one time. And for this I'll store E, I have one time, and for this I'll store, I have F one time. Okay, even let's call it A. so I have a1 time. Okay, now this is really interesting. This is really interesting because when I say I have b1 time, then I'm here showing the map, but actually it is an array of size 26, which is going to give me an array of size like where each element is 0. Only element 1 is the bth index. So if this is a, then this is b, this will be 1, and rest all values will be 0. For this a, all values are 0 and this is 1. For value d, all are 0 and this is 1. So we can do this task in just O of 26, right, which is O of 1 complexity. Okay, so this is how we are able to do this task in O of 1. Okay, now what we can do is, when we come to this point, I will come to this point now, and for this point I can just add up all these values. And what is the complexity of adding these values? Again O of 26. So if I do so, then I will have a1 and b1, right? Okay, now when I move upwards, then again I can add these two arrays, like this array and this particular array. Okay, so when I do so, I will have the answer as a1, b1 and c1, right? Okay, what about this one? For this one I have b1 and I have a1. Okay, now when I combine these two as well, then I will get, I have d1, then I have a1, then I have f1, right? Okay, now I can combine these two values. So when I combine these two values, then I will have a2, b1, c1, and I have f1, right? So this is how we can solve the problem. Okay, I have d1 also. Now this is how we can store our information in segment tree. So now I have the data for each interval, you can see here. Okay, interestingly, what is the time complexity of this? So at first you will say that okay, the time complexity is O of n again. Why? Because we are traversing n nodes, but actually it's not. Why? The time complexity will be, since this is a recursive function, that the time complexity will be, okay, so for this you can see that we are traversing n nodes, so the time complexity is again going to be O of n here, right? Because we are storing each character here. Okay, now this is how we can store the character. So let's talk about how, the approach now, how we can use this particular segment tree in order to solve the problem. Okay, so I have written the same example here which was given in the problem statement. So let's see how we can solve the problem using this example. The first step that we need to perform is build tree, build the segment tree. Okay, now this build tree is going to take some values, which is first of all this is string which is given to us. After that it will take intervals, right? So 0 to n minus 1 is the initial interval that it will take. Fine. Now the second task is I need to traverse each query, right? So for each query I will check some important things. The first thing is, if query type is 1, if query type is 1, what to do in that case? If query type is 1, then I just need to update the value, right? So I can call a function which is update, which is going to update the value in that segment tree, right? Which is going to update the value in the segment tree. Fine. And after this, if it is a query of type 2, in that case, I need to, first of all, I want the array frequency which is needed to be written by this segment tree. So I need to write a function which is going to give me this particular frequency array. So let's call this function as query function. So once I have this query function, so this function can give me this frequency array. I will talk about the time complexity later, but let's say I have this frequency array. So after that, I can simply use this frequency array to find the kth largest element in just of 26 time. How? You can see here. This is something that we can use to find the kth largest element. Fine. Now, this is the approach that we need to follow. So this is the approach that we need to follow, and till now I have not talked about some important things, which are first of all this build tree function, after that this update function, after that this query function, right? Rest all the things I have already explained you. Now first of all, let's talk about this, the complexity of this. It is going to be O of n. What is the complexity of this update function? The complexity of this update function is going to be O of log n. Okay, how this is log n, and the complexity of this query function is again going to be of log n. Let's see how this is log n. So you can see that let's say I need to update the value at this index, right? So what I'll do is I will check what is the interval of this index. Let's say this is 0, 1, 2, 2, right? So you can see that two interval is here but not here, so I will eliminate this whole area for first time. Okay, after that I will come here and you can see that this is 2, right, and this is 0, so I'll not go to this particular part. Again I am eliminating this particular area and I'll go to, so each time I'm eliminating half of the area, right? And this is the similar thing that we do in the binary search. So in the binary search we always eliminate the half area and then we move to the other half. This is how we follow in order to search an element. So the complexity of this is going to be O of log n, O of log n, log base 2, right? Okay. Now, what about the complexity of the query function? What about the complexity of the query function? This is important. This query function is going to give me the answer for a particular range. Let's say I need to find the answer of this particular range, right? Okay. So again, let's say this is 0, 1 and this is 0, 1, 2. So I can eliminate all the elements which are in this particular range, right? Because I need to find the answer for this particular range. So this is how I can eliminate. Again, I can eliminate some intervals, some of the intervals, like if it is 0, 1, 1, 2, then again I can eliminate this whole part. Why? Because I don't need to search for 3 and 5 and even greater in this particular range, because my answer will be surely in this particular area. So this is how again we are going to have a complexity of O of log. I hope this is clear to you. I'll not talk about the complexity later because it is going to extend the size of the video, right? So let's talk about three important functions now: build tree, update, and query. Let's start with build tree function. How we are going to build the tree? I initially have this particular array which is okay, this particular string which is a b c d e f. Now how we are going to represent the tree? The general way of representing tree is basically using node structure, right? Where I have each node and each node have its own left and right. But this is not something which we are going to follow. Instead we are going to follow the array representation. I will follow the array representation to represent the segment tree. And for array representation, always remember one thing, that if I is the node, if I is the node, then left child will be, uh, 2 cross I plus 1, and right child will be 2 cross I plus 2. Okay, now what is the size of this array in order to represent the segment tree? So remember one thing: when we have a string of size n, then the size of segment tree is always a 4n. 4n. Now again there is a detailed explanation on this, why this is 4n. So what I'll do is I'll stick a article, I will attach an article in the description. You can check this article out in order to find this thing, because if I explain this thing, this particular video is not about what is segment tree. This is just I'm going to explain the segment tree in order to make your understanding more clear. But you should know a little bit about segment tree in order to explain this like in order to explain the solution, right? Okay, so I'm not going to explain in detail about the segment tree. Instead, let's talk about the build function. So this is what you need to know. Now let's talk about how we can build the tree. So you can see that I have this string, I have the node. This node is basically going to represent this index. So instead of node, let's call it s of I. Then I have a start and end. Start and end is basically going to represent the interval, because segment tree is all about intervals, right? Okay, so I'll start with 0 and 5. After that, I can divide this interval into two parts, right? On the basis of mid. So if I have 0, 1, 2, 3, 4, 5, so I can put like a partition here. Then I will divide these two, this particular interval into two intervals, right? So I can write int mid equals to start plus end by 2, start plus end by 2. Okay, after this I need to I need to traverse for the left and right child, right? Okay, so how to build the tree for left and right child? I will again call the build tree function. I will say, hey, my task is done. Then now just build the tree for left and right child. So I'll call build tree for left and child. So again, my string is going to remain same. But since I'm moving to left, then it will become 2 cross si plus 1. Okay. And what about this interval? This interval, if this is mid, then the left child will be from 0 to mid, right? Actually from start to mid. So I'll write start to mid. This is the new interval that I have. And what about right side? For right side, I can write build tree string, and then I will have 2 cross si plus 2 here, this, right? After that, I will have mid plus 1 to end. This is what the next interval is, mid plus 1 to end. Okay, fine. Now I hope you have understood this particular thing. So once we have got our left and right tree, so what we can do is we can use these two values to build the array for this particular answer, right? This is what we do. You can see here that we have got answer for this left and this right, and then we are building answer for this particular node using left and right? Okay, so what I can do is I can write here that I will get the array a1 as a left array. So how to get the left array? So if I represent this array with the name segment, then segment of 2 cross si plus 1 is something which is going to give me the left child, right? So this is the left child. Once I have the left child, then again I can have the right child as well. So 2 cross si plus 2. Now I have the left and right child. What to do now? Now my task is simple, that my new node, my current node is going to have the answer as segment of si will be equal to add a1 comma a2. What does this mean? What is this add? Let me tell you about this add. This add function is basically for I equals to 0, I smaller than 26 and I plus plus. Segment of Si of I is going to be A1, like A1 of I plus A2 of I. This is what I'm doing. I hope the idea is clear to you, right? Okay, so this is how we can build the tree. Now, since this is a recursive function, then surely I will have some base condition. So what is the base condition? The base condition is simple, that what is the point when we have leaf here? So we were just dividing the into intervals, then a point will come when I will come to leaf, right? So at this leaf, my start and end becomes equal. So at that point, I need to stop. So if my start and end becomes equal, so if my start becomes equal to end, in that case I need to return. Okay, but before returning, I need to store the leaf data as well, right? So I can simply store the leaf data by segment of current index, which is s of I. And what is this? What is this? What I need to store at this? In order to understand this, let's say I'm at the string was a b c, then I have d a f, right? So I'm at this particular value, because for this 3 and 3 will be there, right? So if 3 and 3 is there, then I can store this particular d at the answer. So how I will store d? I will say str of st minus a is going to be equal to 1 now, right? I hope this thing makes sense to you. So in order to understand this thing, you can try out on multiple examples. This is how we are going to build the tree. Okay, once we have built the tree, let's talk about the next function, which is update function. How we are going to update the value. In order to update the value, let's say I need to update the value at 4th index. So how I can update the value at 4th index? In order to update this, you can see that I'm going to eliminate some intervals. Like I will check what this value is. If this value in is greater than this thing, if this value is greater than the last of this, then I will move here. And if this value is greater than smaller than the first of this, then I will move on the left side. Let me implement this. If I try to implement this, then I will have again a function which is update. Okay, this update is going to take some important parameters. The first is si. What is si? Si is again going to represent the current node in the segment array. This is how we are going to store the tree, right? Okay, so this si is basically this. Okay, now I have the intervals. So what is the interval? Start and end. We always need these three things in order to traverse a segment tree, right? Okay, after that I have position and value. This thing comes from the query that we have, query of type 1, right? Okay, now for this, first of all, let's check the base condition. If I have st is double equal to end, what to do in this case? In order to understand this, I can simply do one thing, that let's say I'm at this particular value. So in this particular value, I need to update the value, right? Because if I want to update the value of 4, so I will somewhere stop at this particular node. Okay, and when I stop at this particular node, then I need to update the value. So I will delete this A, and I will delete this A, and then I will simply increase the index of this A. How to do this? If I have this segment array which is going to give me the segment tree node, then I will do something like segment of si, which is the current segment, and value, this value I need to update, so value minus a. This is how we update in the frequency array, right? This is like, okay, let me draw. This particular thing is a frequency array of size 26, right? So this is how you can think of this as frequency array, or you can think like I'm writing frequency of val minus a plus plus, right? Okay, before this I also need to delete this value which is already here, like a1. I need to delete this. How to delete this? First of all, I need to find the index of this a. So in order to find, I will make index equal to 0 first time, then I will traverse all the indices I equals to 0 to 26. And if my segment of current child and index is double equal to 1, in that case I can surely say that index is equal to I, and then I can simply break. So this way I will have the index, and once I have the index I can simply delete this value. So I will do segment of si and in minus minus. This is how I can delete this value. I'm just reducing the frequency by 1, right? This is about the base case. This is a base case. What about the rest of the code? The rest of the code is simple, that I need to first find the middle, and then I will check whether to move on the left side or right side. Let's see. Mid is going to be equal to start plus end by 2 as usual. Okay, once I have the mid, then I can simply check one thing, that if my position is basically this particular index, right? Position is this particular index. So if my position is smaller than mid, in that case I need to move to left side. So what I can do is I can simply call the update function for the left child. So I will write 2 cross si plus 1, this is the left child, and then I will move to start plus 1. Okay, start to mid for left, and then I will simply write position and val. Okay, similarly I can move to the right child if this condition is not true. So I will write update of 2 cross si plus 2, and then I will write st, okay, from mid plus 1 to end, and then position and val. This is how I can move. Okay, now I have one more thing to explain. Let's say I have updated the value here. I have removed this a1, and then I have made this. Since I need to update the value at, let's say I need to update the value at this position by a. So what I can do is I can make this d as a. So now I will have a here. Okay, oh, there's a confusion. Let me write the string again. What is the string that we have? The string that we have is A, B, C, D, A, F. Okay, so I'll write a string here, A, B, C, D, A, F. Okay, and I need to change this value to E. Okay, so I can write here E1 now, because I have updated the value by using this particular base case. Okay, once I have updated this value, then I need to update the value here as well, right? Because I have D1, A1, I need to make it D1 and E1. So I will update value here as well, then I will update value here as well, then I will update value here as well. So this means that this is again going to recursively update the value for each node from where it came. Okay, so in order to do this, I'll simply do one thing, that a1 is going to be segment of left child. Left child is basically 2 cross si plus 1. This is very similar to this thing. Now we are going to do something like, in order to update the value, we are doing the same thing that we have done here, right? Okay, so my a2 will become a segment of 2 cross si plus 2. This is my left child, this is my right child. Once I have the left and right child, then I can add the values on the left and right child. So d1 and e1 will become d1 e1, right? So I can do segment of si equal to add a1 and a2. Okay, now I hope the update function is also clear to you. So let's talk about the last function, which is query function. I know I'm explaining very quickly, but this is explaining in very detail is going to make this video longer. So let's talk about the last function that we have. We have a query function, right? So query function is si. I need si, st, and for every function. while using the segment tree. Then I have one more range, which is query of start and query of end. Query of end. Okay, now let's see how we can search for the query of start and query of end. The aim of this function, this function is to find the frequency array for a particular range. Let's say I have this range, so I want to find the frequency or array for this range. Once I have the frequency array, then I can apply the same logic that I have like that I have to use in order to find the kth largest element. I hope the idea is clear to you. This is the frequency array that I want to find, this particular array, using the query function. Let's see how we can do this. So what I'm going to do is, I'm again going to check one condition. Let's say I have two ranges, which is query of start and query of end, and here I have start and end. Okay, so first of all, if these two are disconnected ranges, because I need to find I need to check for ranges inside this, right? So if this is not inside this, then I can simply return. So I will check if my query of start is greater than end, or my query of end is smaller than start. If my query of start is greater than end, you can check that. You can check this particular thing. Okay, and again you can check these particular things as well. So in that case, I need to return. I need to return. Okay, so I will return an empty array. So I will return new int 26 of size 26. So this is basically an empty array. Now if my this particular range, which is my current range, is inside this particular area, in that case I will return this particular area. So if my start if my start is basically greater than equal to query of start, and my end is smaller than query of end, in that case I can return the current child, which is segment of si. So let's say you can see that this particular, if I have this range, then this particular thing in is included in this range, right? 2 3 4, then 2 is the part of this range. Okay, so I can return this value, and after that you can see that I have the 3 4 range as well, this particular range, so I can return this as well. Now I just need to add these two ranges. I hope you are able to understand this. So again I'm going to do the same thing, that my mid is going to be start plus end by 2. This is how I will look for a left and right side, right? Okay, so I'm going to look for left and right side. So I can simply do one thing, that I can call a function for, like, I have build. Okay, so what I have here is I have the query function instead of build tree function. So I will call the query function for the left child, which is 2 cross si plus 1. Then I will do start and mid. Then I will again search for query of s and query of end, right? Okay, again I can do for the right child as well. So I'll do, I have si plus 2 and mid plus 1, then I have, and then I have query of s and query of e. Okay, but this function now is going to return some value, right? This function now is going to return some value. This is not a void type function. You can see that this function is going to return an integer array. So I will have the answer. I will have a1 array here and a2 array here. This is an integer array. Okay, once I have these array, I can simply combine these two array. So I'll write something like answer is going to be combination of these two. So I will write add a1 comma a2. Now I'm writing this add in short, but this add again simply means the same thing that I have explained here, that this add means I'm adding the value, right? Okay, I have not written here. Let me explain it again in brief. So this add basically means that I'm running a loop from I to 1 to 20, 0 to 26, 0 to 26. Then I'm adding value a1 plus a2, a1 of I plus a2 of I, and storing it somewhere in the answer. So once I have the answer, I can simply return the answer. This is what we can do in order to solve the problem. Once I have these three functions, so you can simply put this function in the approach that we have. So we can put these three functions here. Now once we have written this code, so our problem will get accepted. This is all about this problem. Let me show you the code now. So I have the Java code on the right hand side, left hand side, and C++ code on the right hand side. Let me start with the main logic. So this is the main logic that we need to perform. You can see that the first task is to build tree here. Okay, and after that we are going to traverse all the queries, and for each query, this is for query type 1 and this is for query type 2. You can see that I'm updating the value here, and for this particular case I'm calling the query function. So three functions are main: update, query, and build tree. Again, you can see that the logic is same for this as well. And if I show you this particular code is for segment tree, you can see that how I'm building the segment tree. The code is very similar to the one I have already explained you, so I'm not going to explain it again. I'm just going to show you the code. Okay, now here C++ code is here, you can see that. Okay, I'm even going to provide this code in the description box. So you can see that this is the main logic for the Python code, and for Python code I have used a different class, which is segment tree class. Okay, so now I hope everything related to this problem is clear to you. So if you guys like the explanation, then you can subscribe the channel, hit the like button, and share the video. This is all about this video. Thank you.